Well, hello, everybody. Welcome again to the G2M Research multi-vendor webinar on scale-out flash storage, breaking old school storage rules. I'm Mike Human. I'm going to be emceeing this. Let me go through the agenda real quick. So I'll do a short 4 to 5 minute discussion about, introduce the webinar topic and talk about kind of the ground rules. Then each vendor will speak for 9 minutes. We have 3 vendors with us today, and I'll introduce those shortly. Then we'll go through 3 panel questions, and those panel questions will be broken up by 2 audience survey questions, which we'd like you to be able to participate in and answer. You can do that through Zoom. After that, we'll have audience Q&A, and we should wrap up somewhere around 10:15 or so. So with us today, we have panelists from Weka.io, from Lightbits and Accelero. With Weka, we have Shailesh. Shailesh is head of AI and Strategic Alliances at Weka. From Lightbits, we have Josh Goldenauer, who's the VP of Outbound Marketing, and from Accelero, we have Tom Layden. And again, I'm Mike Human. So what is scale-out flash storage? I always get asked what this acronym means. I didn't invent it. I actually found it somewhere, but it seems like a good one. It really is the idea of taking a software package and servers of one sort or another that contain, in most cases, NVMe-based storage devices, and kind of molding that into an entire network, which typically runs under a single namespace. If you think about where SOFS has come from, it's really evolved from 2 different places. One is software-defined storage. If you remember companies like, there's a variety of them that were out, Falcon Store, companies like that, that say 10 years ago did this software that they run on top of a storage appliance, which tended to be a server with a lot of storage devices in, and then they could share out storage. People used to call it a poor man's array back in those days. So that's one place that SOFS has come from, but it's also borrowed heavily on what people like Google and AWS have done by taking basically servers and putting a lot of DAS in them, or direct attached storage, and then weaving it together into a namespace. That's probably closer to what SOFS really is. And one of the things that's really revolutionized SOFS and kind of enabled it is NVMe over Fabrics, which really gives you the ability to remotely shared storage devices with performance that's very close to what you can get on the local level, and latency as well. One of the things we'll talk a little bit about as we go through some of the use cases, if you look at SDS really struggled to be accepted. It was never really thought of as much more in a poor man's SAN. It, oftentimes had the worst of both worlds in that you had to buy the hardware, you had to buy the software, and piece it all together. But that's something people have done, previously. I think the bigger issues tended to be around the fact that you had limited flexibility in the structure because it was all based on SAS and SATA. So if you look at SOFS using NVMe, most of those limitations have gone away. If you have a node that can be a compute node, it can be a storage node, it can be both of them. The network topology can be changed around however you want, and that really gives you the capability of having a software-defined, or software-orchestrated structure. And then finally, the remote performance storage really approaches local performance storage. So the penalty you pay for having a network storage solution really has gone away. And then, I think the other big thing is the fact that now you can put together thousands of nodes. It really solves a problem of how much storage am I going to need and where do I need to put it, which has always been an issue, not just for software-defined storage, but also for storage arrays as well. And with that, I'd like to introduce Shailesh. Shailesh is, as I said, head of AI and Strategic Alliances at Weka. Shailesh, go ahead.
Hey, thank you, Mike. Good morning, good afternoon, folks. Thanks for taking the time. So just to point out everything Mike talked about, scale-out file storage. So we are essentially an file system, basically grounds up, designed and architected for NVMe flash and leveraging technologies like NVMe over Fabrics, but also going a step beyond and leveraging technologies, latest technologies like GPU Direct and so on. So my presentation is primarily divided into 3 parts. We'll talk about what we are seeing in terms of the new workloads when it comes to the likes of AI, ML, and DL data pipelines. We'll talk about the changing architecture dynamics now, the edge becoming a lot more prominent and with an inflection of AI, ML. And finally, we'll make it all about the data, right? So it's really about, how you manage your most strategic asset, the data, how you're able to make this as your competitive differentiation, how you're able to gain, really valuable insights in a timely fashion, right? Actionable intelligence. That's what we are going to talk about. Okay, next slide. Okay, so real quick, we are based out of here in San Jose, Campbell. That's where our office is. Engineering is based out of in Israel. Marquee investors, we claim ourselves as the world's fastest file system, and I'll show you some proof points to support that claim. We have several patents been filed and been also issued. And a very strong and kind of leadership board. Next slide, please. Also, we have some marquee customers across several verticals, whether it comes to genomics, machine learning, financials, pretty much workloads which have the same characteristics around perform and needs for performance at scale. Okay, and we'll talk about that a little bit more deeper, but across pretty much all verticals. Next slide. Okay. So when it comes to actually, this new applications, if you see, one of the primary characteristics of this new applications around AI ML is performance at scale. Okay, and if you take an example of an ADAS use case, you are able to illustrate this a lot more better. I mean, we work with this use cases a lot. We have customers around this. And what you would see is depending on what kind of autonomy you're trying to achieve, whether right from 2+ all the way up to 5, the number of DNNs you would use changes, right? And also depending on what kind of infrastructure the car deploys in terms of, the megapixel of cameras, how many cameras, and so on and so forth. But as a rule of thumb, each survey car spits out about 2 petabytes of data sets per year. Okay, so if you multiply that by number of survey cars an ADAS company uses, you would get a sense of how much data sets we are talking about, right? And also, when it comes to deep learning and DNNs, those are only as good as the data sets they have at their disposal and the access they have at their disposal to these data sets. Okay, next slide. Okay, the second thing about this applications is really the architecture, right? So as I said, the edge is really becoming big, and with an inflection of AI ML. So you see a real landscape and an ecosystem develop around it. There are several startups playing in that field. There are big and small companies, but it's all really about inferencing. So edge is all about inferencing, where you're able to basically execute on top of this DNN. Then there is this concept of fog, or really edge aggregation, where you are aggregating all of this data sets at an edge aggregation point. Okay, and we have a play at the edge aggregation, not so much at the edge endpoint, right? A perfect example of this would be an parking lot project, where you have all of this survey cars coming into a parking lot, uploading all of that data to an edge aggregation device, which then does some level of ETL processing, extract, transform, load, and then uploads this either into an core and the edge, right? And the core and the cloud. And the core and the cloud is where most of the training happens, okay? So that's kind of a landscape of the new architecture. Next slide, Mike. Okay, and where do you see this, right? So AI ML started in its infancy, but now you can see this go across the HPC, the high performance computing market, to the high performance data analytics market. Okay, and obviously AI ML use cases are proliferating all the verticals, right? A couple things to point out, take an example of, for example, genomics as a use case in the HPC landscape. You would see accelerated compute there. And it's not necessarily just GPUs, but accelerated compute also comprises of FPGAs, they comprise of graph processors, and so on and so forth. And the need for access to data is very similar when it comes to any of these accelerated compute layers. Same thing with high performance data analytics. You would see use cases with the rise of open source frameworks like Rapids and so on, where you would see now the whole end-to-end pipeline, whether you're doing ETL processing, whether you're doing extraction or you're doing deep learning, all of that can be GPU accelerated. Okay. Next slide, Mike. Okay, so now having said all of this, storage becomes a bottleneck when it comes to these pipelines. And if you look, these applications are very different than the typical file system applications, which are based on read, modify, write, or a lot of contentions, a lot of readers and writers, right? That's not the case with when it comes to these pipelines. But these pipelines have each phases which have varied storage requirement. When it comes to ingest, it's all about massive write bandwidth. When it comes to enrichment or ETL processing, it's about capabilities of how you enrich that data with labeling, how you can index those data sets, how you can search them quickly. Okay, when it comes to training, it's all about read bandwidth, okay, massive read bandwidth. When it comes to validation, it's really about lot of random read writes and the ability to support large number of streams when it comes to validation and simulation. Then you get to inferencing, which is all about low latency. And then finally, you get to lifecycle management, which is really about keeping versioning and so on and so forth. Okay, next slide. If you see, existing storage architectures fall short when it comes to particularly meeting the requirements. If you look at DAS and SAN, you got to typically customers use them as with multiple servers, with EXT and XFS file systems on top of them, and you end up copying that SAN data sets multiple times into that compute layer. NAS, it solves the ease-friendly or user-friendly requirements, but it falls short of performance. When it comes to object, it's good in terms of durability, but it falls short in terms of performance. Also, the applications have to be rewritten. So there is this new category which is emerging. Mike, if you can build that slide up, right? Where there is need for this, what we call accelerated data ops. This category needs to basically accelerate, the operational aspects of data. It also has to cater to the performance requirements, right? What directly results into faster time to market for an end customer. You got to be able to derive actionable intelligence, whether you are running, big data analytics or deep learning, or all of that on the same storage substrate. It needs to enable shareability and collaboration. It needs to have mixed workload support, has to have cloud native and hybrid capabilities, and finally enterprise readiness, right? So this is a new emerging category, pretty much what Mike has been talking about earlier. Okay, next slide, Mike. Okay, it's a huge market. So coming to what we do, right? So this is a file system, as I said, designed from a totally grounds up for NVMe flash, taking into account all the latest technologies. So on a high level, you would see a file system. This is an POSIX compliant file system. We also support NFS and SMB with data services. Mike, if you can build it up in the interest of time. Okay. Very rich data services. We can do encryption inline. We can scale up to several nodes across 1,000 nodes. Okay, and several of those. Networking stack, which is something which you have built grounds up, encompassing either RDMA or fabrics. Okay, also leveraging new architectures like GPU Direct and so on and so forth. Okay. And then finally, support for all kind of transport, whether it's Ethernet, Rocky, whether it's InfiniBand, and so on. So this is how you see actual WCAFS file system deployed. So we can run in a converge mode where you can run on the GPU servers directly. Okay, we run as an LXC container on the servers. We can run in a disaggregated mode. We support, what we do is we leverage on-prem object store as well as public clouds in a very unique fashion. And what that means is we are able to extend the file namespace over the object storage, whether it be on-premise or off-premise. And it's very unique capabilities in the sense that we keep all the metadata. So it's really not tiering, but it's really about extending the file namespace over those object stores. Next slide, Mike. And we'll go into this more details as we answer some of the questions around differentiability and so on. Okay, so what do we bring to the table for data scientists and CDOs and CAOs, right? So these are new personas whom we now need to talk with, leverage them as the influencers. So it's really about the fastest, inferencing time, the lowering of the epoch times significantly, the highest number of images per second benchmarks, okay? And what this results into is directly affects the top line and the bottom line, right? And we claim, our claim is to be faster than local storage, okay? In fact, going a step beyond what Mike said, okay, and I'll show you proof points to support that. Next slide, Mike. Another important thing when it comes to this new pipelines, it's not just about performance, it's also about, how do you explain this, this capabilities around, because for the most part, the DNNs are black boxes. So in order to explain that, you need to keep a tab on what are the data sets you are using, okay? So our instant snapshot capabilities, whether you're doing on 50 terabyte or doing on a 2 petabyte of data sets, become extremely important. We also have a capability about snap to object, where we package the metadata and data together, create a tarball, which can be used for keeping a tab on the experiments and also being able to reproduce those experiments, okay? So very important capability. One more slide, Mike, and then I'll wrap it up. Okay, so this is a proof point. We hold the highest performance when it comes to the IO 500 benchmarks. The top left graph talks about how we differ when it comes to performance with NAS and also local NVMe. Right, so almost 12 gigabytes per second to a single GPU server, 73 gigabytes per second using GPU Direct, which is the bottom left graph. Okay, also highest images per second spread over almost 9 DGXs. Okay, so I'll pause here, Mike, and then we can come back to some of the question and answers. Okay.
Perfect. Thank you very much, Shailesh. And now I'll go next to Josh. Josh, go ahead and take it away.
Okay, thanks very much, Mike. Why is Lightbits on this conference call someone you should listen to? And I would just want to start out by saying that the folks at Lightbits have been around for quite a while and have been involved in NVMe before there was even an NVMe. So, some of the folks that founded Lightbits and that are still here were the first to do NVMe SSD controllers. And then our CTO, for instance, was on the NVMe.org committee that standardized NVMe over Fabric, including the version, for RDMA. And finally, Lightbits pioneered and developed the NVMe over TCP protocol, or NVMe over Fabric utilizing TCP. And not only did Lightbits develop this standard and participate in the standards boards, the code that was developed by Lightbits is actually now what is in the upstream kernel. So, if you use NVMe over TCP and you get it directly from the kernel, that is code that was directly contributed to the upstream kernel from Lightbits. So we are the experts in this field in NVMe over Fabric, and really believe that the key differentiator here was, although things started with RDMA, TCP is so much easier to use. It's so ubiquitous. It's basically everywhere, that it really was felt that that's the way to go ahead and deploy these things in the future. Next slide, please, Mike. So if we look at what drove us to this point, you look at the data center and market trends. And really what we're seeing here is that you've got flash, dropping in cost like crazy. So it's becoming more and more affordable to use. You've also got the fact that bandwidth is cheap. Now we think of 100 gigabit as something that's fairly commodity. We've got 200 gigabit NICs that are out, and there's already 400 gigabit interfaces appearing in switches and some routers. So bandwidth has gotten ridiculously cheap. And along with that, the latency has also dropped. Applications, we're seeing applications that scale out over tens or hundreds of servers at a time. People are adopting hyperscale practices, which is basically moving to cloud native applications. And lastly, this idea of when you want to do private cloud is that you want to emulate the hyperscalers. So you want to go for ultimate operational efficiency, and hyperscalers innovation is basically tomorrow's enterprise practice. So when you put these all together, what you find out, it's really about flash being as cheap as possible, enabling CPUs to run as fast as possible, but you want to decouple CPU from flash. You want to, that is, separate the CPU and the flash so that you can grow them independently. So you need a simple and efficient storage scaling software platform that can help you do that. Next slide, please. So let's look at what's using these kind of things. We've got this transition to cloud native applications. And hopefully if you're building your own private cloud or you're working in the cloud, you've seen this. You have all these common applications, and there are many, many more. Generally, they're NoSQL, they might be in memory, they could be distributed, they could be classic SQL or NoSQL. But the point is, all these applications share a need for low latency and sometimes high bandwidth. They need consistent response time, because if you're building a web service or you're building modern applications, every application depends on another application. So when you get inconsistency in one, that trickles down the chain and you get inconsistency to the end user experience. So these are usually deployed on local flash, that is flash inside the systems. And usually they're also bare metal deployments because you don't want any virtualization overhead to get in the way or make your application run in an inconsistent fashion. But when you do this, when you put flash inside every application server, you suffer from poor local flash utilization. That is, somebody always has to make the decision about how big that drive is going to be. And they're always going to choose larger than they think they need because no one wants to be the person who chose a drive that's too small. So you put in a drive larger than you need and you end up with chronic underutilization of this resource. Secondarily, now when you have a drive failure or a host failure, you know you're going to have a long recovery. If you have an 8 terabyte drive and you're running Cassandra, for instance, it could take you anywhere between 2 and 6 hours to recover that drive. And all that while, you're really taxing your network. And lastly, if you're doing high amounts of flushes, you could run into flash endurance issues. It's very attractive to try to go after things like QLC NAND nowadays, but if you write to QLC NAND in the wrong way, you actually wear it out very, very quickly. Next slide, please. So the answer to this, of course, is LightOS. LightBits is the company, LightOS is the product. And LightOS is a disaggregated, virtualized NVMe that goes over TCP, and it performs like local flash. So you get yourself high performance, software-defined storage, because we all want to use commodity servers and have very high performance there. You get to scale storage and compute independently. So now you don't have to couple a fixed size of storage to your compute and either have too much compute power or not enough compute power or too much storage. You scale these things completely independently and dynamically. It uses a standard infrastructure, that is standard clients and servers, and of course a standard networking protocol. If you know how to do TCP, you can run LightOS and you can do remote NVMe over a protocol that you know. You don't have to learn anything new. If you know how to do port bonding and routing and MLAG, these things all apply to this. You don't have to learn any new protocol. And this is going to help you reduce cost. It's going to maximize your flash utilization, and you're going to increase your flash endurance. LightOS has a complete flash manager in it that makes sure that when you're using QLC, for instance, it makes sure to write linearly and in large blocks so that you make that QLC last as long as possible. And this all improves your operational efficiency. When you break the tie between applications and servers, it means you can run your applications on any host and you can just attach to your storage. So you're no longer binding where an application runs with the amount of storage that's inside it. And lastly, you can do all this with rich data services. And this is really the differentiator. When we talk about NVMe over fabrics, I used to call that remote DAS. It's very common to get extremely high speeds, but no data services. But LightOS performs like local flash, but it does it while still offering thin provisioning, compression, of course, dynamic volumes at scale. So you get data services that you're used to in things like all flash arrays, but it performs like it's local NVMe. Next slide, please. So, what does this look like in practice? So this first slide is what I described when you're deploying your applications. on servers that have local NVMe. You can see the pros are basically that local NVMe drive is very fast. But the cons is that you might be limited to one drive. Or if you choose multiple drives, you have to deploy some kind of RAID or some kind of striping, which is going to affect the performance. So you tend not to do that. You tend to pick one drive. When a drive fails, you're going to have that severe impact on the network because you're going to rebuild due to a drive failure or a server failure. Either way, you're going to copy maybe 4 or 8 terabytes completely over the network and saturate your network. And finally, if a server fails, you have to do a full drive rebuild. So you don't have any choice there. There's not going to be any recovery of that. You're going to have to do that. So next slide, please, Mike. So this is what it looks like when you deploy LightOS. So you take the drives out of your servers. Instead, they're going to get virtual volumes, and you're going to have some number. You could have these in a cluster if you want failover. If you don't want to do failover, you can just have independent servers. And your SSDs are going to be a pool of SSDs. You're going to require far fewer because you can go ahead and provision volumes to the exact size you need, and you can use thin provisioning. So that if you don't know the exact size you need up front, you can deploy what looks like an 8 terabyte volume, but really you're not using the storage until you need it, and you could add drives at a later time. So you get local NVMe drive performance, and now drive failures don't have any effect on those applications. So when you have Cassandra or MongoDB or CockroachDB, and I just like saying CockroachDB, by the way, if you have a drive failure there, the drive failure is going to be completely handled by LightOS. It's going to be rebuilt by erasure coding within the unit, and you're not going to affect the application at all. Those volumes can be any size. We talked about that, and thin provisioned. And on a server failure, now you can go ahead and launch a new instance of that application on any other server on the network. And it could be anywhere that's routable. A key difference between NVMe over TCP, and of course, NVMe over Fabric. NVMe over Fabric with RDMA is switchable, but there are questions on if it's actually routable. So this way, you can go ahead and launch a new instance anywhere on the network that's routable, and it can pick up from where it left off. So now your rebuild is only going to take minutes instead of hours. This is going to lessen your network impact, give you higher uptime, and of course, increase any chance of meeting your SLAs. And it's going to reduce your SKU count because now you can normalize your server. You don't have to have different servers for different purposes. Next slide, please, Mike. And so lastly, we put this all together. Lightbits, software-defined storage, NVMe over the network, over TCP. You pick your servers, and it feels just like it's local flash, but you get the services commonly associated with all flash arrays. You pick your standard SSDs, and with that, you'll get thin provisioning, compression, data protection, of course, quality of service, higher endurance. If you want to use QLC, you're going to get higher endurance because we're QLC optimized. And optionally, there's a hardware accelerator to go ahead and do compression at line speed. So you can get full 100 gigabit line speed. And this all runs on a TCP IP network that you know and love with standard NICs. So there's no reason to go buy different NICs than the ones you're used to or the ones that are on your motherboard. You can go ahead and use those there. And lastly, no proprietary software. In the case of Lightbits, if you're using an upstream kernel, if you're using Red Hat releases and whatnot, the NVMe over Fabric TCP initiator is built into the software. So you don't have to load a driver. You don't have to depend on anybody to go ahead and do a compile for you, or worry about if there's a security issue and you want to change your kernel. You don't have to wait for a company that's supporting you to provide a proprietary driver. It's in the upstream kernel and it will be there forever. Standards based with full multipathing. Multipathing comes via the ANA standard. And this is all part of the NVMe over TCP client driver. So certainly hope that you'll think about Lightbits and give us a try. That should be it, Mike.
Thanks a lot, Josh. That was excellent. And just to let everybody know, I had said this earlier at the beginning, but I'll say again, we will answer all the Q&A live after the presentations and after the panel questions. So with that, let's go to Accelero and Tom Layden. Tom, it's all yours.
All right, thank you, Mike. And you can move to the next slide. So I'll try to be short to make up for some of the extra time that others have been speaking. Thanks for the invitation to speak here. So I'm VP of Marketing at Accelero, and Accelero does scale out elastic NVMe. I like to think that a strong product story always begins with the drivers behind it, and more in particular, the market drivers. So what we're seeing is innovation drives innovation, and the dynamics in the markets. It's really interesting to see how new technologies enable new applications, and how those new applications on their part then require new technologies. So what we're seeing in the market is that modern data centers are today increasingly running data intensive workloads. Cloud, what used to be typical cloud providers, today are running more high performance workloads, AI workloads, and then the typical high performance data centers from before are moving towards the cloud. So in essence, what we're really seeing is the convergence of what used to be cloud, HPC, and AI markets. These are all converging into what we like to call the high performance data center. Both in the cloud and at the edge. So as those modern data centers are adopting those new workloads, those new high performance workloads, what we're seeing is that they need to double capacity and processing power about every 18 months. And what they also need to do is they absolutely need to maximize their data center ROI, and that counts for compute, that counts for storage, for networking, and for applications. So that's what you're seeing on this graphic here. For example, on the storage side, companies need to maximize their NVMe utilization. On the application side, it's always very interesting to reduce hardware utilization to lower your licensing costs. On the compute, when companies deploy GPU servers, for example, they need to ensure that those GPUs are used at maximum utilization. And I believe, as storage is the backbone of the modern data center, that we have an opportunity here to help our customers optimize their ROI across the entire data center. So by selecting NVMesh, or Elastic NVMe solution, our customers actually optimize the ROI across the data center, including storage, compute, networking, and the applications. Next slide, please. So I found it interesting, Mike, that you see scale-out flash storage as the next generation of software-defined storage. I'm not sure I entirely agree. I think this is a new paradigm, but it follows nicely after software-defined storage, and I think both are going to exist next to each other. It's my belief that NVMesh is both SOFS, but it's also software-defined storage. So first things first, NVMesh is SOFS. Why is it SOFS? Well, we enable Elastic NVMe through NVMe virtualization. So what you see on the left is our stack. The bottom layer, you will find standard commodity servers with NVMe, and we abstract the NVMe capacity in those servers. So like some of the others you've heard talking, we support converged and disaggregated architectures, or a mix of that. And what NVMesh does is we abstract the capacity of all the NVMe drives, and we create one elastic pool of NVMe from which we take capacity and create logical volumes, say virtual NVMe devices, right? So in our architecture, we have a distributed architecture, so there is no controller bottleneck, and we ensure that you get local NVMe performance across the network. What does that mean? Well, if an application server accesses an NVMe device across the network, so an NVMe device that sits in another server, it will have the same performance, the same low latency, as if it were a local NVMe drive. So what's also cool is we are a pure block solution, and we support any local or distributed file system on top of us. Gives a lot of flexibility to our customers. And talking about flexibility, we leverage RDMA for very low latency, but also TCP/IP if desired, or the standard NVMe over fabrics. We believe that as such, NVMesh is the most flexible soft solution available on the market. Really allows you to meet the requirements that your application and that your business has from a cost and performance point of view. Next slide, please. But NVMesh, in my point of view, is also software-defined storage. And what do I mean by that? We are a 100% software-only solution. Accelero has no business with hardware. We leave that to our partners who do that very well. So in essence, customers can choose any hardware platform they wish to use. That goes for servers, that goes for NVMe devices, or for networking. Also, we use the lowest overhead in all meanings of the word, enabling you really to maximize the data center ROI. We separate the data plane, control plane, and the management plane, which I believe was the essence of software-defined storage years ago when it first came out, and we believe that's very important for efficiency as well as for performance. We support, as you can see on the graphic, both converged or disaggregated architectures, or it can be a mix. So customers can decide to just share NVMe devices, as you can see on the left, between servers, and each server will be both a target and a client. Or if customers decide that they suddenly need a lot more capacity, they can add a few servers that are filled up with NVMe devices. And we provide flexibility in data protection, where you can choose to replicate your data or use different flavors of erasure coding. All right, next slide, please. We too are deployed across many customers in many different verticals. We have an indirect go-to-market, which means that we always work with a partner. We believe partners are essential to our success. We've got tens of production customers. Here you can see a few that we're allowed to name publicly. A couple of the interesting ones that I'd like to point out, about which you can find more information on our website. InstaDeep is one that I always like to talk about, because they were the customers who helped us understand the value of NVMesh for GPU environments. InstaDeep, they had DGX servers from NVIDIA, and they found out that they needed much more storage capacity than what the DGX has internally by default. They tested a server, an NVMe server from Boston with NVMesh software on it, and the tests actually showed that the performance that they were getting from that external box of NVMe was actually faster than the internal flash that they had in their DGXs. So that was a great win for them to be able to add more capacity. Then a second one that you can see, there's Orange Cloud, a big web customer for us. Besides AI and GPU storage, scale out web service providers is another big market for us. And then I invite you to come to our website, accelero.com, to explore our other use cases which are documented in, or case studies which are documented in much detail. Mike, shall we switch to the questions?
Perfect. Thanks a lot, Tom. I like how you tied the SDS and SOFS together. I thought that was pretty slick.
Oh, cool.
I agree with the approach. So let's jump to the first question. So first we'll have Weka answer this, and Lightbits and Accelero. And that first question is, each of you has deployed a large number of SOFS solutions. What do you see, if you name one or two leading use cases that you've seen in your deployments with your customers?
Yeah, Mike, so I'll take the first one. Clearly, as I said, the use cases, what we see are across verticals, and I'll point out at least 3 verticals, right? But they essentially, the requirements there are performance at scale. For example, with AI ML, I mentioned about the ADAS use case, the automated driver assistance system. Okay, so that's an use case where, as I pointed out, lots of scale of data, but also it's important to be able to, reduce your, be the first to the market, and also reduce your time to value, right? So that's one vertical. Second vertical is around life sciences, genomics. So we see customers using us with accelerated compute layers, for example, in terms of FPGAs. For example, we have a customer using FPGAs with Illumina sequencers, and the data which comes out has to be processed extremely faster at a performance layer, but also has to be managed, data managed. And the third vertical is around FSI, where you have really a need for high performance and lots of data sets when it comes to things like back testing and doing fraud analytics and so on. So those are the use cases, examples of use cases, what we see in those three verticals. Okay.
Excellent. Josh, how about you guys at Lightbits?
We're actually seeing and or focusing on a different set. So it's very interesting to hear the differences. At Lightbits, we're mainly going after databases, both traditional ones as well as scale out distributed open source, things like Cassandra, MongoDB, Kafka, CockroachDB, et cetera. So really seeing databases, especially distributed ones, going out. And then public cloud providers, that is the smaller ones. So folks that want to compete, maybe have a specialty to compete with like an Amazon or an Azure, and they want an EBS-like functionality out of the box. They don't have the budget for tens of thousands of developers. So they want to provide something like EBS, Elastic Block Storage, and so they can just buy the Lightbits product and put that into their cloud. And with the functions we have, it gives the necessary functionality to work for a public. And then the flip side of that is private clouds. So most corporations are looking at moving to cloud, but not just to moving to cloud services. They want both. There's sometimes that they have data that they can't move, or that they just want the speed that's afforded or latencies by local networks. So they're developing private clouds, and they want to do what the hyperscalers are doing, but they also can't afford to go out and develop everything new. So those that are looking especially to migrate to OpenStack or Kubernetes are very good targets for what we're seeing for scale out flash services.
Excellent. We'll talk a little bit more about cloud, one of the later questions as well. So that's interesting to hear that. Tom, how about Accelera? What are the big use cases you see? I know you talked a little bit about them in your presentation.
Yeah, I did, but I think there's a few more things to add. So as I was saying, I think the paradigm SOFS, but also SDS, they were in my point of view, they were designed to be deployed in as many different use cases as possible, and that probably is the reason for the question, right? So proof of that is NVMesh has been deployed across many verticals for many different use cases. Think of HPC burst buffer, video post-production, analytics in both financial and medical verticals, use cases with government organizations that I can't really dig into, enterprise databases, data warehousing, so a lot of different use cases. But from a deal size point of view, I think our key vertical is the scale out web market, where also scale out databases is probably the leading use case. And then second would be artificial intelligence, again, across verticals. Like I said, those verticals are sort of converging together. So based on this current mix of verticals and use cases, we sort of try to simplify how we split our markets. One side is everything that is CPU based, so databases, mostly scale out, but not uniquely. And we're talking mostly about cloud service providers and enterprises there. Enterprises typically seen as their own cloud service provider with their internal private clouds. And then second part is where the compute resource is a GPU, so everything AI, machine learning. But I've learned from our partners in NVIDIA that we actually should be talking about deep learning, because that is where we really bring value with this super low latency, high bandwidth storage. And it's really interesting. We've been doing a lot of work lately with NVIDIA, and what I've learned is, even though our product was designed mostly with scale out web use cases in mind, when you look at the key requirements that GPU customers have, we're a one-on-one fit. So questions that we're getting from GPU customers and also from our partner there is, or requirements that we're getting is data needs to bypass the CPU. Check. That's been one of our key selling points from day one. Absolute minimum latency. I think we have the lowest latency in the market at Accelero. Eliminate storage I/O bottlenecks. That's what we've been designed for. Share NVMe across DGXs, but also be able to add capacity externally if needed. So that's the story that I brought to you guys about being able to do converged, disaggregated, or both. Scale linearly, supporting existing AI workflows, which means not forcing customers to use a new file system. So as a final note, our experience is that customers largely come with three major requirements: performance, resilience, and scalability. And we are very good at providing this performance at scale. So in a very space efficient, robust solution, which is also good for the edge, and very averse to complex failure scenarios.
Excellent. Thank you very much, Tom. Now I'm going to launch the first audience survey, and this question is, does SOFS look like a solution that makes sense for your organization? It's a check one. Go ahead and fill those out. I'll give you about 2 minutes and we'll post the results. With that, we'll go ahead and start panel question number 2. And that question is, what best practices would you suggest to a potential customer who's using a SAN or NAS storage solution today and would like to migrate to an SOFS solution? We'll start with Lightbits and then go to Accelero and then to Weka. So Josh, you want to hit this one? Josh, are you there? I think you're on mute.
The poll is in front of the question. That's what it is. Sorry about that. So best practices, I'd say, is basically you want to, and I'm assuming this is around the best practices, things you want to do in the business when you're thinking about migrating or you're actually actively moving. And the first one
Correct.
is simply identify your applications. Don't think that SOFS is for everything. At the end of the day, when we're talking about scale out flash solutions, they are high performance. So not everything, honestly, is going to make sense to move. There are still some things that are going to stay on spinning. And you know what? That's okay. It doesn't have to replace everything. So identify your applications that are highly transactional or otherwise latency sensitive. These are the ones that are candidates to migrate to SOFS. High bandwidth, low latency. If it's underneath a file system, you know, things that are creating tons and tons of very small files or reading lots of very small files. So these are, identify the right candidates and you'll have a better chance of success. And then also keep in mind that moving to these solutions, especially when they require RDMA, is going to require changes to your networking practices. So I've been other places where you kind of surprise the company's networking team that one particular team says, yeah, you know, we're thinking about this new solution and we just need to turn on the settings for RDMA and Rocky, and said, oh wait, we don't control the switches. We have to talk to the networking group, and then the networking group is taken by surprise. So, you know, just keep in mind that depending on the solution you choose, you may be making an impact, so you definitely need to get the teamwork there. And lastly is, you know, try different things, shop around. Don't pick just one. Because different people are going to offer different things, and you want to go ahead and get the one that works best for you. So I encourage you to try other solutions for ease of use, as well as their performance and whatever aspects are important to you.
Excellent. Tom, what have you guys seen as best practices in doing a migration to an SOFS from a SAN or NAS?
All right, very good question. What's interesting is what we're seeing when we talk to customers, and not only here at Accelero, I've seen it in previous storage companies as well. Cost is always a very big driver in making storage decisions. In essence, that's not an issue for us because we're very, very cost efficient. And as I was explaining, we're actually aiming at optimizing ROI across the whole data center. But I think cost should never really be the driver. So for me, a first best practice is think in terms of ROI. So that is already, so not cost, and that is already a first good step in the right direction. But then ask yourself questions: how will this new storage solution impact my application? What's the storage efficiency? And what's the data center footprint? Okay. Then another best practice would be to check if the new solution disrupt any existing workflows. It shouldn't. If a system does not support your go-to file system, might have a big impact on your projects. Or if the storage system does not support the network that you're using, again, could be another problem. Then thirdly, what's really key in my opinion is that you have to make sure that the solution provider provides all the flexibility and that your storage is future-proof. So storage requirements evolve a lot as you introduce new workloads, new applications, as data storage capacity requirements grow faster than ever before. So obviously, you need to make sure that the storage solution of choice meets your current application and business requirements. But you also have to think ahead. What if I need to scale capacity faster than planned? How granularly can I scale? I mean, you want to avoid forklift upgrades. Can I scale performance as needed? Maybe separate from capacity? And will I be locked into the choices that I make now? Think of networking, storage servers, data protection choices. So to conclude, we have found that performance at scale is critical, but none of these on their own can replace the base necessities from a storage solution. So extreme robustness to various modes of failure. That's it.
Excellent. And Shailesh, what would you see as best practices?
Well, yeah. So good question, Mike. I would actually start with start with the business goals. What are you trying to achieve? That's first and foremost, right? Second is start small. Wet your feet, get a feel for whatever solution you're trying. Is it on the right direction? And then finally think about, well, it's not just enough to just wet your feet. How are you going to operationalize this solution, right? And that's where I think most of the failures come across when you try to operationalize it. So that's going to be very important. The other aspect is, as you think about the whole pipeline, try to break silos between, some of these new personas whom you leverage in a digital organization, whether it be, data scientists, chief data officers, chief analytics officers, and the IT guys. They have to work together to be able to come out with an effective solution. So that's the second aspect. And also on that same aspect, it's important to look out for a solution which can cater to a whole pipeline, right? Not just parts of those pipelines. Otherwise, you end up being into several silos. So that's another important thing to keep in mind. And then finally, you got to leverage the economies of scale when it comes to the public cloud, right? So public cloud does offer some benefits. So what's your strategy when it comes to leveraging public cloud, whether it be in terms of cloud bursting, when it comes to offering a SaaS-based solution, and so on and so forth, right? So try and look for an hybrid solution if at all it's possible. Okay, so those are the three main things which I would like to put forth as best practices.
Excellent. Our next audience survey question is, how do you see SOFS fitting into the overall storage solution environment? This is a select one. I'll launch that. And with that, we will go to the third question, which is, hybrid cloud and private cloud architectures are becoming commonplace in enterprises today. What advantages do SOFS solutions have over array-based solutions in that regard? In other words, if you're going to combine hybrid or have a private cloud, how do you see SOFS as being particularly good for that? We'll start with Accelera, then we'll go to WECA and Lightbits. So go ahead, Tom.
And here I was looking for the mute button. All right, so I can only speak for ourselves. NVMesh was conceptualized, as I explained before, with cloud as a primary use case, and with help from some very large cloud design partners, both in the private and public cloud space. So this has led to some architectural decisions that are really key for these markets. I mentioned the shared nothing architecture. We have no controller bottlenecks. And we enable customers to scale capacity and performance granularly as they need. as I mentioned, no forklift upgrades needed. But here's also where true SDS comes in play. Data path separation, 100% software only, no hardware dependency. And then finally, I need to go back to flexibility again. So the ability to design the storage architecture that meets your application and business requirements now and in the future. And then also your choice of NVMe drives, your choice of networking, your choice of file system.
Excellent. Shailesh, how do you see you guys fitting into the cloud, multiple different cloud architectures?
Yeah, great, Mike. So I think this is where we really differentiate ourselves. I mean, this is one of the key value propositions, what we bring to the table compared to the other parallel file systems out there in the market. And the way we do it is we are able to leverage either a private cloud or a public cloud, okay, and in a very unique way. So what we do, we work with a number of object storage partners. We have actually an object storage ecosystem which works with us in tandem, okay? And what I mean by that, it's not really tiering, as I was explaining earlier. What we do, we extend the file namespace over the object storage, okay? And what that means is we are able to basically keep all the metadata when it comes to the whole file namespace, okay? And it provides us some unique benefits. It's able to amortize the cost of the flash over the hard disk based object storage, right? So in a true sense, it brings out the hybrid cloud benefits. In the same fashion, we're also able to connect with a public cloud, okay, where we are able to extend those same benefits to over a public cloud environment as well. So you can have leverage public cloud in tandem with the NVMe on-premise flash, okay? The second thing we bring to the table is the ability to take a snapshot both for the data as well as the metadata. And we call this snap to object. And what this is, think of this as a tarball, which comprises of both the metadata and the data. Now you have a complete view of that file system, and you can move this to a public cloud where you are able to dehydrate it. You are able to basically expose it to a public cloud-based file system. So by the way, another important aspect is we have a SaaS offering as well, pure SaaS offering, which can run in AWS. So once you take this tarball, snap to object tarball, you can basically rehydrate that in the cloud for test dev environments and you know, also starting to wet your feet, you know, in the public cloud. So those are some of the very unique benefits which none of the existing parallel file system vendors have.
Excellent. And Josh, I know you talked a bit about cloud. You want to take your shot at this one?
Sure. So, you know, cloud is undeniable. And, you know, what a lot of folks are running in the cloud is either virtual machines or containers. And so we're taking the approach that you take the block and you standardize it out and you offer drivers like Cinder for OpenStack, like CSI for Kubernetes and container environments. And this naturally makes the workloads very portable, because if you're running containers in the public cloud and then you go ahead and run containers in your private cloud, you can use the same kind of semantics. You're going to go ahead and use volumes the same way. And then moreover, we are of course examining running LightOS in the cloud because we're just TCP based. We just simply need instances in the cloud that support NVMe. And basically all the major cloud providers are providing NVMe instances right now, though their instances tend to be a little expensive. So by running us in the cloud, you can go ahead and you can put those together, and then things like thin provisioning and compression that's offered in our product that's all in software can go ahead and make use of those. Instead of being thick provisioned and paying for a lot of money, you can actually go ahead in the cloud and have our software manage those devices. So those are the things we're looking at. In the meantime, though, until that kind of thing is released, you could simply use these plugins, use standardized environments, and move back and forth.
Outstanding. And with that, we've got a couple questions. Let's go to the Q&A part and the polling here real quick. First question we have is, this was aimed at light bits, but we'll let each of you guys answer it. And the question is, you mentioned QLC flash needs special treatment, presumably right coalescing at the very least. What kind of special treatment optimization do you apply? So we'll start out with you, Josh, and we'll go to the other panelists after that.
So Jarrett is right on track. What makes QLC cheaper is that you've got 4 level of bits in the cells, and it needs special handling. So what happens with these drives is that, especially to address this much space as well, vendors, and I'm not picking on Intel, this is happening across, but I do know the Intel QLC drives moved from a 4K block to a 16K block. So if you don't write to those drives in at least a 16K block size, you are going to take the endurance of that drive, and I think you get like 1/100th or something of the endurance. So you can really wear the drive out. If you look at the spec sheets for the Intel drives, they'll actually tell you 2 different numbers for the endurance. That is, if you write to it in large blocks or if you write to it in small blocks. So the point is, yes, the light bits, specifically in the flash management layer, is always appending. So it uses a journal, and it does in the kind of controller running in software what a FTL on an individual SSD does. So it's managing all the flash in the pool the way a single controller manages a single SSD. So we're always writing sequentially, and we're always writing in large blocks. And if you go ahead and write to QLC in large blocks and sequentially, you get the most endurance out of that.
Good. Let's see. Shailesh, do you want to try to talk about what you guys do there, or Tom, either one of you?
With computational storage?
The question was about QLC flash. Do you do anything to specially treat QLC flash?
Well, yeah. So today we support NVMe flash. QLC flash is coming. Okay. So, but yeah, everything what Josh was outlining has to be an consideration, right? We support today NVMe flash for the performance tier and SDD object storage leveraging SDDs, which comes out really well because you're now leveraging performance of the NVMe flash and the capacity advantages of SDDs.
And Tom, do you guys do anything special for QLC?
Besides that, we support any existing or available drives on the market right now, and that we will be supporting future drives. I don't think there's much to add to what Josh already said.
Okay, sounds good. Next question we have is, how would SOFS work with computational storage? I'll leave that open to the panel and let you guys answer that. Whoever wants to jump in, feel free to do so. Any takers on that one?
So Michael, I mean, computational storage is still in its nascency, okay? And essentially, most of the action is happening with, the hard disk drive vendors, okay, where they're implementing, some form of classification also on the hard disk drive using some AI stack in an FPGA. Okay, so it basically enables better classification of the data, better querying of the data, and so on. Okay, it doesn't really change a whole lot when it comes to a file system accessing computational storage. Yeah, I'll leave it at that.
Yeah, and I would tend to agree with that. I mean, I'm fairly familiar with computational storage, and it's really a matter of, and the whole magic there is moving workload onto the storage. I don't know that it changes how you treat your storage from that perspective. So,
yep.
I suppose if you had a mixed environment, maybe. Yeah, go ahead, Josh.
I guess I would pipe in here to say, honestly, today, the answer is no, it doesn't work. So, because right now computational storage is going to rely on, I mean, I think all the computational storage today relies on, sometimes even when they look like they're NVMe devices, which is common, they're counting on the fact that they're on the PCIe bus and they can have multiple devices being addressed, and there's special libraries you use to enable your applications to use that storage. And they kind of basically depend on the fact that that storage is local today. So as soon as you virtualize out that storage, that awareness is not there. So you'd have to get the industry to kind of come together on a standard that would combine, like with NVMe over Fabric or something, to know that maybe this NVMe over Fabric device also has computational abilities. And then that would have to be extracted through any virtualization layer. So it could be off in the future, but probably right now they're not really compatible.
Yeah, I tend to agree with that. Last question we have is, how does billing and cost for capacity handled? Are there multiple tiers, performance levels available? What options are there for backup and archiving data? And do you want to jump on that one, Tom? And then we can go through each of you guys and talk about it.
All right. So we are a high performance primary storage solution, and we present block volumes. That's the bare essence of that. We do not provide backup or archiving functionality. Let me be very clear on that. We don't have a billing engine either. You would have to provide your own billing engine if that is what you need. But what's really interesting in NVMesh, and that goes back to my answer on one of the previous questions, is we do support all available NVMe drives, even just standard flash drives as well. So if there is a need to manage, let's say, different volumes, different tiers with different grade drives, that is perfectly possible. It's perfectly possible to create block volumes leveraging your best performance NVMe drives for certain applications, and then using other drives, maybe just standard flash drives for lesser performance, but also maybe at a lower cost for other applications that require less performance. So that is absolutely supported, but the billing part, that would not be.
So I think this person's question is, so from your perspective, you just charge, you do not sell on a per capacity standpoint. I think that's what the question's asking.
Sorry, say again? I didn't get
yeah, sorry, I was saying, I think the question is asking, do you bill on a per capacity standpoint? How does your software bill? You know, if you buy an array, you're paying for X amount of storage, right? So I think the question is for each of you guys is, you know, what does your billing look like? I think that's the question.
Oh, our billing model. I thought there was.
Yes.
I was confused because of the different tiers, performance levels that were asked for. Okay, thanks for clarifying that. So it's a software license. You buy software from us. Okay, very sharp pricing. Majority of the price is still the hardware, but like we said, we work with the commodity servers, and going back to the performance level and the tiers, as we support different drives, it's up to you to design the system according to your performance needs, and as such, pay the money, only pay the money that you need to pay, and then we will support all of those drives, but we are just a software license.
Excellent. Josh, you want to address that from your guys' perspective?
Sure. We're also a software. We don't. We basically charge per node or per storage server. So we don't charge you extra if you get larger drives. You don't pay that per capacity penalty. Some vendors charge per capacity, but that's the Lightbits way is to go ahead and charge you per node, so that as drives get denser and larger, you're not going to owe any more money. If you swap out those drives, you know, that would be your thing to do. And multiple tiers, yes, the product supports multiple tiers within one system, multiple different storage pools, and you can allocate from those pools. And then if the question was at all on chargeback, it's a very rich API, RESTful API for determining actually what's used versus what's allocated. So you could actually, if you had your storage divided into pools, you could figure out how much was being used by who.
Excellent. And then Shailesh, for
so-
Weka, what does your guys' model look like?
Yeah, so again, it's a software defined. We sell perpetual licenses based on capacity. Okay. And as I said earlier, we would have, and it's not mandatory. We are a high performance file system, a parallel file system on top of NVMe flash. But if the customer wishes to expand that or an HDD based object storage capabilities, we would be able to extend our file namespace over that object store. Okay, so we can support multiple tiers. Okay, and the second question around options for backup and archiving, yes. So in our case, it's all built in. So we can take a snap, to object, we can move that to a private or a public cloud. You don't need a special backup software for doing that. You don't need anything additional besides us. So we have the built-in capability to be able to do backup and archiving for the data sets.
Excellent. Well, thank you again, everybody. I appreciate both the attendees and the panelists for this webinar. Hopefully people found it interesting. Again, we'll post the recordings of the webinar by Thursday, and we'll send everybody who's registered a link to both the recording and the link to the slide set. So with that, thanks again, everybody, and have a great day.
Thank you, folks.